Good evening, respected faculty members. So I am Sudhir, embedded lead for this particular Sense Semiconductor and IT Solutions Private Limited. So by today, we are going to close our embedded hardware part. Mr. Sai Shankar bit occupied with client project. So that's like second half of the hardware part is taken care by myself. And from tomorrow onwards, Miss Ropa is having 8 years of experience as embedded firmware engineer, and she is from, I guess, Qualcomm or Intel. She is from Qualcomm, I guess. So without further delay, we just want to start our last day of FDP regarding hardware design. So feel free to today. I just want to focus about conclusion of this particular PCB, like how as of now we discussed about what is PCB and what are the major components.
Sorry for the interruption. Yeah, some of the faculty member asked regarding recording sessions. Every day we are sending the recording session to your mail ID, and also learning resources also. Please check your mails. Thank you. Continue.
Yeah, thank you, Surya. So today, as a part of PCB design, we discussed about what is PCB and why PCB, and followed by what are the different tools and softwares we are going to use for PCB designing, and followed by different major key terms about PCB designing, and followed by schematic designing and layout and Gerber files, and what exactly AI will impact entire hardware manufacturing process. This is how we discussed in the last 5 to 6 days. Today we are going to completely going to discuss about how exactly industry will produce the PCBs, how the industries will manufacture the PCBs. So today we are major focusing about manufacturing. And one more thing, guys. So today only we received one of our PCB. So just give me a second. This is what one of our PCBs. So this PCB today only we received from our manufacturers. This is complete design and manufacturing and procurement, everything like firmware logics and mobile application, everything was developed from our team only. So this is customized PCB we designed for VVIT University. So for VVIT University people, we developed this particular thing. So this is what AC control unit, timely based and temperature based, and it logs the temperature. So you can see their brand name here. So these are the PCB we made for VVIT University for their complete academic blocks and hostels automation. So let me explain how we did this particular thing. And later on, from tomorrow onwards, somehow Ropa is taking care about firmware designing. So what are the standards? Simply, this particular topic almost it will take 10 days. Sorry, hardware will take 10 days and firmware will take 10 days. But somehow due to the time constraint, we just want to conclude hardware by today itself, and firmware will be started from tomorrow onwards. So let me explain how we did this particular thing. Okay, so you see about the particular hardware, right? So this is my screen is visible for everyone. Yes. Thank you, Sarvana. So this is what software we done for VVIT people. Let me start from starting. So this is what the admin dashboard we made for VVIT University people. It is VVIT U AC monitoring and control unit. So this is what the login. So there are eight hostels for students and 5 to 6 academic blocks. As a pilot project, we did for 2 hostels, hostel 1 and hostel 2, and each and every floor there is a configuration. Each floor is consisting of 32 rooms, hostel rooms, floor 2 and floor 3 and fourth floor. And this is about blinking is representing of control unit is having internet or not, and these were timely configuration. So it is about on schedule, and it's about all hostels are specific hostel, and out of specific hostel all floors are specific floor, all boards. Like there are 2 corners. Our control unit will control 16 rooms, 16 AC set. But basically in their floor there are 32 rooms. So we designed this particular unit for 16 units, 16 AC controlling, and these kind of units 2 boards will be there, board 1 and board 2, and we can set one time or every day and weekdays. So schedule will be implemented for every day or else weekdays. If it is like every day, at what time we should on the ACs, all the ACs, and we can set the off schedule for all hostels or specific hostel, which floor and which board, or else all boards. Is it for one time or else weekdays or weekends? Because weekdays they will go for classrooms, and weekends, Saturday, Sunday, they basically stay in the hostel, so that configuration may change. In the daytime also, they are required ACs in the hostel rooms. So we need to configure the off schedule and on schedule, and we need to submit. So this is one thing. And second thing, our control unit will capture the temperature and current readings. So we can see like which AC is consuming more power. We can select specific month and year and week. So we can go for each and every floor, and each and every floor we can go for a individual AC power consumption. AC 15, power consumption is 62 units. So these kind of analysis we can do. Our control unit will capture, it will record the current sensing and temperature. So it will project all the information in the dashboard. So these simply like we can do the time configurations. At the same time, we can control each and every room individually. So this is about simply about the software part we did for VV8 University for AC controlling it. It's for entire campus automation. We currently working on entire campus automation. As a part of campus automation, we did for hostels and classrooms. Now we are working on solar based automation for VV8 University. So this is simply about our work contributions for different institutes and organizations. So we did products for Syngene pharmaceutical company, which is the international pharmaceutical company, and Rockwell people, and VVIT University people, and there are 8 to 9 clients. So we provide all the hardware services like these kind of PCBs. Is my screen is visible for everyone? So this particular design, so already we discussed like for any circuit analysis, first we should go for a hardware designing. Once hardware designing is done, then we should go for a schematic drawing. Once schematic is done, we should go for layout. Once layout is done, then we will finalize our Gerber files, BOM file, and PNP file. We should send these files to the manufacturer. Once manufacturer are available with all the stuff, once he is having this particular bare PCB on, once he is having components availability, everything will be purchased from the vendors itself. We will purchase the PCBs and we will procure the components, everything assembled at our end. Once assembly is done, we will go for hardware testing. So once all the tracks are correct or not, these kind of analysis will be done. Once that hardware analysis is done, then we will hand over this particular PCB to the firmware team. Firmware team people will take care about the final application. So software people will go for a software developer. This is what complete embedded product. So for this particular PCB, we used all the AI technologies. Like for BOM, we are used AI BOM verified tools. We generated the BOM and we applied BOM to the AI tools. So if the component's lead time is too high, then it recommended this particular component you can eliminate. So we eliminated that particular thing. And same thing when we are placing PNP file and design file, like some of the components, let me showcase. So I will go through schematic as well. If you see, like there are 2 components mismatching is here. 1 is 2. These footprint are mismatched. As a AI tool, it recommended us the whatever the PNP file you provided and the whatever the BOM component you provided, both are mismatched. Before sending to the manufacturer only, we understood like where is the mistake. Like there is what the component unavailability. So we said like proceed further. Like once we receive the components, we are replacing the component by the time of receiving. Today, this particular assembly is done at our office. So these kind of recommendations also provided by AI. So now we see detail about how industries are working. So let me today my major agenda about how we are. So basically typical this is what the typical block diagram of our product. So power segment will be there. Let me showcase each and everything in detail. This was the power segment and USB type C for code downloading purpose. This is what ESP32 room 1 controller and max 485 for intercommunication. In a hostel room, there are 5 to 6 different floors, ground floor, first floor, second floor, third floor, these kind of pattern will be there. So but they are providing internet for only one module. So that's why like we are making all the units like a loop pattern. So it will communicate from one control unit to other control unit. So master slave concept for data exchanging, we are using max 485 for both UART and Modbus communication. So from ESP2 we are using shift registers and hex inverters and followed by relays. So these are the simple block diagram. So these were the circuitry. These are the schematic. These were the controller block, and these were the USB, and these are the 485 block, and these were the power segment, and these are what the shift register block, and these are hexainverter block, and these were the relay headers and relay screw connectors, and these were the relay circuitry. 16 relays section will be here, and followed by MOV circuitry, surge protection circuitry for relay. So these are the some of the circuitry we made for this particular thing. These are like once we done with hardware designing, then we will go for schematic. First, for any project, these were the actual flow of any particular project for hardware. These were our company official document. So first of all, we are going for specifications. So for any project, what exactly required? So we are assigning PCB number and version number, and whether it is a double-sided PCB or single-sided PCB. Okay, and PCB name and grouping. It comes under smart building in our office. So these kind of information should require. And for any PCB, these are the some of the modules we need to work on it. One is specifications, hardware specifications. And if any modifications with respect to the previous versions, we will mention like what are the modifications for the next version. This is the version 1.0. In the next version, if we raise the version 1.1, we will keep the reasons why we are going for a updation. And thereafter project architecture and block diagram, and followed by schematic diagram. Once schematic diagram is done, we'll go for bill of material, BOM, and position diagram. So once BOM is done, once schematic is done, we will mention that schematic team, hardware designing team will provide the position document. Position diagram, it's all about where exactly the component supposed to be placed. It's a rough diagram, I can say. It's a rough diagram where the component should be placed. So that is what the position diagram. And then layout team will go for a layout, and PCB designing will be taken by the layout people. And once they will see about 3D view, before sending for the manufacturer, they will go for AI tools. Basically, whether the PNP position file, position and BOM is mismatched or not, both are okay or not, whether the components availability or not. So these kind of checklist will be, and everything will be through to the verified. Once all the stuff was verified by the AI tool, then we will go for manufacturing. So these what all the stuff. So before going for a design, like in the initial previous sessions, we discussed about track width and track length. So there are three types of power supplies are there. One is 5 volts domain, 3.3 voltage domain, and ground domain. So each domain we will calculate what is the power. So on 5 volts, okay, what is the current required? It's 1320 milliampere. So for 1300 milliampere, so we will fix the for a extra provision we are keeping. Like as per calculation, we are getting 1320 milliamperes, but we will give the provision for 1500 milliamperes. So width of the track is 0.5 mm. So these kind of calculation will be there. So width of the track for 5 volts around 0.5 mm. Similar thing for 3.3 volts. So almost 500 milliamperes is required. If Wi-Fi is active mode, then we are giving almost provision for 1500 milliamperes. So coming to the GPIO, there is 20 milliamperes current required. These kind of calculations we did. So 0.25 mm track width is enough. So for COM, NO, NC, 30 amperes current is required. As it is the AC, so almost 30 amperes current is required. So for 30 amperes, we are giving 2.6 mm provision. Okay. So these kind of calculations we did. So after this particular calculation, we will go for a block diagram and system architecture, and thereafter schematic using Altium tool or as KiCad tool. Depends on client requirement and our requirement. So these were the top view of the PCB, and these were the bottom view of the PCB. So these were the 3D view of the PCB. So let me showcase some other photographs as well. So these were the bottom layer of the PCB, and let me showcase. So these were the top view of the PCB. So these were the controller section. These were the USB section, code downloading section, and we are facing issue here. If you see SW1 and SW2, at the time of manufacturing only we got these particular comments, but we ignored and we said like do not mount. So they sent PCB without these particular components. So these were the control section and code downloading section, and these were the power section. 5 volts power section will be there, and these for external communication, Modbus communication. This particular connector is for Modbus communication, and these are shift registers, The longer ICs are shift registers, and the smaller ICs are encoders, hexa inverters, and followed by these were the optocoupler and transistor is there, and TVS diode is there, and these were the relay, and followed by these were the surge protection, and these were AC controlled external connections. So these were simple AC unit, customized AC control unit. Like it's purely depends on end user requirement. So now we will see about how we design this particular thing. Shall we go into the presentation now? Today we will see about how we did this particular thing using particular PCB manufacturing process, PCB assembly and testing. So today we are going to discuss about PCB manufacturing process, how these particular PCBs are manufacturing at the industry, and thereafter PCB assembling techniques, SMD versus through hole. There are two types of components are there: SMD, surface mounted devices, and through hole. It's a whole kind of through hole will be there. Like there will be a hole, and we need to dip the component. Dip component is there, and SMD, surface mounted component. So there are two types of components, and two different techniques are required, and soldering techniques and best practices, and multimeter and oscilloscope for PCB testing. Once we receiving this particular PCB, we need to, like hardware team need to take care about multimeter and oscilloscope for continuity testing and signal, whether signal is generating or not. This kind of testing is supposed to be done before hand over this particular PCB to the firmware team, and followed by hands-on testing, fabrication PCB, and debugging common issues. Like what are the common issues we will face at the time of PCB fabrication, and once PCB getting the PCB assembly, and AI-based manufacturing validation and debugging support. So these were today's topic. And coming to steps in bare PCB manufacturing. First is design and output. So we will go for a PCB layout design, and we will prepare the Gerber file and review for manufacturability, whether the components are available, whether that is feasible or not. And second thing is material selection. So we need to set the material such a way that those should be available, and the lead time should be very, very less. Then only it will be more suitable for the component selection and scalability. Okay. And the next one is inner layer imaging. So there are like top layer and inner layer and bottom layer. So we need to give each and every design in the design files. So basically we can say like circuit patterns are printed onto the copper clad. So which are things going to be printed on the copper clad, we need to provide that particular information. And etching. So these were the inner layers will be first of all printed, then etching. So etching we already discussed, like Mr. Sai Shankar discussed. Etching is removing of excessing copper. So initially entire copper will be poured onto the bare PCB before these were the initial step. Thereafter we need to go for a etching process. Whatever the excess amount is there, we should remove, and whatever the needful component circuitry, that will be remained on the PCB. So let me, once this particular presentation is done, let me explain with our PPT, or else now only I will explain. Just give me a second. So is my screen is visible for everyone? So if you take this is the PCB. Okay, initially everything was copper poured. So these are the tracks, right? Rest of the things will be etching. Rest of the thing will be went under etching process. So they will remove the unwanted process, and the wherever the track is there, wherever the track with proper clearance, the rest of the thing will be etched. Rest of the thing will be removed. This thing will be remained same. So then only there will be a track will be found between one component to other component. Rest of the thing will be etched. So if you take anything. So if you take, this is one kind of width, track width. Okay, here the track width is bit lower. These were the GPIO, and these were other signal. Depends on our previous calculation, we will go for a track width, and this is what we call as minimal loop area, and track clearance. These were the track clearance from track to track. Okay, so let me explain some other components. So these are what the loop mounting holes. This one. So all the components will be placed, like we will keep the connectors, and this particular thing will be mounted on the particular PCB, particular housing. So these are what the mounting holes. These are the connectors. Okay, And let me show. This is what the SMD component. Entire thing will be on the PCB itself. So we can say this is the SMD component, and there are some dip components. If you take this particular resistor, this is what the dip. Like there is a hole, and on hole it will be dip into the particular PCB. So whatever the dip components are there in the back layer, they will be reflected like this. So on back layer, on the bottom layer, we will go for a soldering kind of thing. Okay, and we will see about vias. If you see here, there is no track. If you see here, there is no track. Some connection is happening here. So there is via, and here is via, and here is via. If you see, are you able to identify? Like small kind of holes will be there. This one, and this one, and this one, this one, this one. These are the vias. If you take top layer, let me keep both the images side by side, then you will get clear idea. So here are the vias, right? Here are the vias. So those wires are reflected here. See this, see here. There is no connection on the top layer. The connection will be happening in the from the bottom layer. These are the wires concept. So here if you see, there is no track. Like there is a track from this point to this point, but from here there is no particular thing. So that will be started from here. From here, other track will be started and it will be terminated from somewhere else. Since and this connection is supposed to be taking place here, okay, but there is no chance to overlap. From if we take connection from top layer, if we take the connection from top layer, there will be a overlapping of this particular tracks, so there is no possibility. So there is a via from vias, okay, they are taking other connection from here and they are passing to the other component. So these were the concept of this particular vias, and these are the dip component. Dip component we are getting on the other side with a hose. We are going for a soldering. And what are the other components? There are n number of components are here. If you see, there are other components here, but there is no connection here. There is no connection is here. So we can say these components are SMD components. Okay, we'll get back to the presentation again. So etching process will be taking place, and layer alignment and lamination will be taking place and drilling through holes for vias and components for like drilling will be taking place, and thereafter pathing PTH holes will be taking place, and outer layer imaging etching. So inner layer first we will take care about inner layers, and later we will focusing on outer layer. Again on top layer, outer layer, we will go for a solder masking. Solder masking like green color masking, red color masking, black color masking. This kind of solder paste will be applied. So we can say it is the proto kind for short circuiting. So if you go for a masking, so it will prevent short circuit from one component to other component. So surface finishing and silk screen printing. Silk screen printing simply about now you see about SSIT logo and VVIT logo and component nomenclature. All are comes under silk layer printing. So thereafter final printing and profile cutting. So these were the various steps involved in bare PCB: design and output, and material selection, and inner layer imaging, etching, and pH planting. It's all about holes, and outer layer image and solder masking and silk screening printing, the nomenclature, and final testing. These were the sequence of activities. So if you see steps involved in bare PCB, we already discussed. So this kind of design and output should be there. And once we get the PCB, and material selection should be there. Once the material selection is done, then we will go for etching and layer by layer alignment. First, we will focus on bottom layer 1, layer 2, layer 3, and finally outer layers. So again drilling holes and outer layer, finally top layer and bottom layer, and planting, and finally soldering the components. These were the PCB, bare PCB manufacturing life cycle. Now soldering techniques. We already said like SMD is there and through hole is there. Through hole, these kind of holes will be there, and on holes components will be fit. SMD components are directly mounted on the PCB surface without any drilling holes. No drilling holes is required. These are very small in size and more compact design. While we are going for a SMD, the size will be very, very less. So it is more preferable. But the difficulty is it's difficult to solder. Manually, it's very difficult to solder. and for mission, it is very easy for soldering. If it is like a mission soldering, assembly is more preferable. Thing it is very simple for mission, and the cost and the space of the PCB will comes down. Okay, we can say like cost effective for mass production, and automated placement is there, faster for production with mission, and easier to automate. Typical requires less manual labor to maintain due to the fewer issues with loose or missing pins. Like if it is like a machine soldering, assembly is more preferable. So first they will apply the solder mask using stencil. Stencil is nothing but, so let me explain. These were the very important for important term for any PCB design. So stencil in homes, you are going through these particular designs, right? How did you get typical Indian people will get this particular designs? So there is a fixed design, okay, fixed design. So on design they will go for a colors. So finally we will get that particular design, right? So these kind of things, these are the called stencils. Same thing for PCBs as well. So these kind of designs will be there. This is we call as PCB stencil. So once this particular design is done, stencil, solder mask will be applied. So solder mask will be taking place where there is holes. The rest of the part won't apply for solder mask, since that thing will be stopped here. Rest of the part there where there are holes, the solder mask will be applied in the holes. So that is what the first step. So applying solder paste using stencil. So wherever there are holes, there solder mask will be applied. That stands for there is a component, we need to place the component. Once the solder paste is applied, then we will place the components using pick and place machine, PNP machine, pick and place machine, and heat the PCB in a reflow oven to solder the components. Automatically that solder paste will be evaporated, like it comes under liquid state. So it is, once we are heating that particular PCB, and it is very easy to solder then. This is what the process with assembly. And through hole is very easy for soldering, manual soldering. If it is like a manual soldering, this is the best thing. And for prototyping also, we will go for a dip component, because it is very easy for soldering. So high manpower is required, but easy to maintain. We can easily maintain. If it comes for repair, we can easily do that. But coming to maintenance, assembly is very difficult. We won't get any issues with assembly, but once it comes to the production, like supporting, it's very difficult to troubleshoot. It's very difficult to re-solder. Coming to the process, simply we will insert the component leads into the PCB holes, and then we will use the solder, and we will use the hand soldering. Like there is no machine for this particular through hole components, and we will cut the excess elements. You see this particular PCB, everything was properly cutted. There, if you take end of each resistor, it's almost 1 inch. We will cut the extra material, excess leads. So soldering techniques, we will see about soldering techniques. So there are two things. One is for THT, through hole components, manual soldering is there. Simply we will hit the gun, and we will place the solder wire, and with the heat of this particular soldering gun, that solder wire will be melted. That's how there will be a connection will be happening. So these were the hand solder, but the pollution, those who are involved in the manual soldering, they will get the long-term diseases, breath related and lung related issues will be taken. Like that was the polluted air. So there is a lot of precautions we should take care while we go for a manual soldering. And coming to the assembly, simply solder paste will be applied, and assembly components will be placed using pick and place, and hot air will be applied. Then soldering will be takes place. That's it. That much easy. So once that particular PCB is done, we will go for a multimeter for continuity testing. So first, once we receiving the PCB, it will go for a quality check. Quality assurance team will take care about quality check, whether all the components are placed or not, whether the right components. If it is like a resistor one with 100 ohm, by mistake, if they place 120 ohm, it is a issue again. So they will check whether the components, all the components are properly placed or not. Once, and the right component is placed or not. These kind of things will be taken care by quality assurance team, QA team. So once everything is done, they will go for approval for the particular PCB. Then it will go for a mission testing. Okay. Once we receive the PCB, we will keep that thing in the high temperature conditions. So whether it should be survive, it should be sustained for high temperature conditions. No component on the PCB should not melt. So one more thing, there are some precautions we should take care. These particular, I guess my camera is visible. So these kind of connectors should not place. These connectors should be placed only after heat test, temperature test. We will keep all the PCB in the ovens, which is running at 350, 400 degrees centigrade. Okay, but we should not keep the plastic related elements which are sensitive to the temperature. We won't mount. There is a mounting instructions. We will only mount after that particular temperature test. So again, we are keeping in the cold test. Okay, all the environmental testing will be taking place. All the mission related testing and strength related testing and circuit testing, entire thing will be taken care by quality assurance team. So once everything is tested, then it will pass it to the hardware team. Hardware team will take care. They will take the multimeter and oscilloscope. They will check whether the continuity is available or not, whether the rightly connections is taking place, whether the signal is we are receiving the signal or not. These kind of testing will be taken care. Whether the for protocols, whether we are getting the SPI, I2C, UART signals or not, these kind of analysis will be there. If there is any EMI or noise effects, everything will be taken care by hardware engineers at the time of module level testing using multimeter and oscilloscope. So now we'll see about hands-on testing. Once we receive any PCB, there will be major these kind of things will be there. First, if we receive any PCB, first thing we need to check is whether there is any shorts or not between VCC and ground. If there is any short between VCC and ground, we should not power up. If we power up the PCB, entire circuit will be damaged. Before power up, we should check the power on test, whether any shorts between VCC and ground. If it is okay, then it will verify. And second thing is verify correct voltage levels. If we applied after VCC and ground no short, then we will apply the voltage, and each and every point we will check whether the right voltage is receiving or not at each and every IC. If IC is designed for 5 volts, if we are getting 3.2 volts or 4.5 volts, then it should not work properly. So we will check the voltage level at each and every component. This is what the power on test. And we will check functional test, whether all LEDs are properly working or not, sensors and buttons, and we will give the test points. Okay, so whether we are getting the useful information in the test points or not, these kind of analysis will be there. And coming to the debugging, if any issues, no power, then we should know about whether there will be a short circuit or else loose connections. And no signal, that means cold solder joints, like missing components may be missed in between the tracks, or else no proper soldering. So then we won't get any signal. Then we should re-solder the PCB and check the connections again. And overheating ICs, incorrect power supply. Instead of 3.3, if you provide 5 volts, there will be a chance for overheating of the components. So we should verify the voltage and current ratings of each and every IC. And communication failures, wrong baud rate setting and broken traces will lead to the communication failure. Then we should check UART, SPI, I2C settings and the pins configuration. These are the regular debugging things for any industry guy. So now we will see about how AI impact entire design for manufacturing validation and debugging support. Simply think, AI validates the Gerber files and manufacturing data. Once we done with the design, the Gerber file will check for completeness across copper, silk screen, whether all the names are visible or not, and solder masking layers, whether any excess solid solder mask is taking place or not. This kind of everything will be checked there, and it will compare the Gerber file to the source file to detect the export errors. Any errors are not there or not while we are exporting the files, and detects any components missing or any drills, any wires are missing. So these kind of stuff will be validated. And AI powered BOM, bill of material analysis and optimization. Once we're done with our bill of material, we will upload that BOM file to the software. So it will check whether the component is available or not, whether this is the right pick or not. This kind of thing is produced by AI tools. So ensuring manufacturing ready design packing compatibility, whether that is available or not. Okay, DFE analysis. So these are some of the steps we are following, ensuring PNP file is matched with Gerber file or not, BOM file is verified, and whether components are available or not, whether lead time is less or not. This kind of everything will be checked in the AI tools. So structured AI assisting during debugging. So we can set the signal and we will generate the signal and we can load the signal. So once we are getting this particular data, we can upload data to the AI tools. It will analyze whether we are getting the proper signal or not. So these kind of recommendations are done. And if there is any high temperature, this kind of thermal evolution will be there, and feedback network checking, and current path traces. If any current traces are available across the component, it won't recommend. So these kind of recommendations will be provided by AI. That's all about manufacturing process. So we discussed about how we design PCB. So now I will open for doubts. So you can ask your doubts if you are having any. So that's all for today's session. And thank you each and everyone. So that's all about hardware part. So from tomorrow onwards, Ms. Rupa will take care about firmware sessions, like how can we do the coding and how AI helped for this particular thing. So dear faculty members, if you are having any doubts, feel free to ask me. So requesting, like as a founder, so every year as a part of anniversary, we are hosting scholarship. As we are from rural agriculture background, we are the founding of 4 members. We all people from rural agriculture background. So we know the difficulty, how as a students, how, we face so many difficulties, so many problems. So as we started our company, it's running successfully. So we thought we should every year as a part of our company anniversary, every year we should donate something. So as a part of our CSR activity, every year we are hosting a scholarship exam. So like last year 1.2 to 1.5 lakh we provide scholarship. This year we make 1.8 lakh. So it will be very useful for the students, those who are skilled and looking for financial support. So if you're having doubts, please let me know. I will be waiting here for 5 more minutes. So these kind of PCB we can get at the end. Yeah, Mr. Zin, sir, all the PPTs are uploading, and you are also getting the mails with PPT links. All the PPTs are there in the Google Drive itself, and every day they are sharing. Yeah, Mr. Chandrika. So every day you are getting recording sessions, edited recording sessions through mail. Please check your mail, ma'am. How many layers are used for this particular design board? So we are using only 2 layers. Sarvana Kumar, thank you, sir. Thank you so much for your support. And PPTs are there in the Google Drive. Please check your mail. Explain about JTAG, Srihari sir. So JTAG basically, I can say JTAG is meant for 2 things. Okay, one is for code downloading purpose, one is for debugging purpose. For advanced controllers, firmware tools itself having a simulations. So this particular JTAG will be helpful for simulations to get the like how the firmware is flowing inside this particular hardware. So to track each and everything step by step, that JTAG will be helpful. It's a simple words I can say. Is it clear, Srihar Garu? So it was my honor to teach great minds and who can train a number of students. So it was my great pleasure to working with you guys. So deliver whatever the knowledge I am having. So if there are any mistakes, please apply. Like as I am your student, so it's my great honor to deliver things to faculty like you guys. So hope you will train as many as students. If you are facing any difficulty, if you are having any doubts, feel free to reach us through mail or else WhatsApp. So our team always there to support you guys. Our ultimate goal is upskill the students and build a good future. As we are the young engineers and entrepreneurs, we are doing everything on our own. We know the difficulty, like how the industry is running and where are the gaps between industry and academia. So I guess this thing fulfills a bridge between industry and academia. Like these kind of stuff won't be dealt by in industry experts. Like they are conducting FDP or some XYZ as a name of as sake of name. But we are very genuine. We are doing all the activities for good, better future. So thank you everyone for joining. So have a great day, guys. So
Yeah.
any doubts?
So can I take over?
Yes, please.
So first of all, I would like to thank our founder CEO, Mr. Sudhir Reddy, for his valuable insights, and our team for their constant support, and our faculty members. So don't worry, guys. From tomorrow onwards, we are going to have embedded firmware sessions by Miss Rupa. And one more doubt: where is the institute location? Sir, we are not an regular training institute. We are a product development company, and we have a industry-oriented training programs, which is handled by our learning platform called Sense Academia, and we are headquartered at Mangalgiri, Andhra Pradesh, and we have branch offices in Hyderabad and Bangalore as. So this is all about our company. So that's it for today. Recording sessions and learning resource materials will be shared to your mail. Please check your mail once. Thank you so much once again. Have a nice day. Bye bye. We'll meet again on tomorrow. Bye guys. Bye my dear faculty. Thank you.